Okay, hopefully you've had time to print these problems out and give them a try. I'm going to show you how to do these. So that first problem there, you need to get this solved for y in the slope-intercept form, so get y by itself. First, get rid of that negative 3x by doing the opposite. Remember, 8 and 3x are unlike terms, cannot add those. So just write it with the x term first and the 8 second. Next step, opposite of timesing by 2, dividing both sides by 2. Everything on that right side gets divided by 2, so I'm going to split it up into two little fractions. One fraction is 3x over 2, and the other one is 8 over 2, which gives me 4, because remember, 8 divided by 2, that's where that 4 comes from. Now, with y by itself, it is ready to graph. That 4 is where you put your first coordinate on the y-axis. That is the y-intercept. The slope, or the rate of change number in front of x, tells you from that starting point where to go. So 3 over 2 represents slope, which is rise over run, means every time I go over 2 boxes, I go up 3. If you run out of space, be able to stair step the opposite direction, down 3 over 2, down 3 over 2. All of those points on that line have that same rate of change, going over 2, up 3, over 2, up 3, over 3, up, over 2, up 3. So that is the equation y equals 2 or 3 over 2x plus 4. Okay, next problem. This is a absolute value equation, so that means you have two different numbers, two answers you're looking for. Both 10 and negative 10 work in here. So you set the equation up equal to whatever x is to get you 10 and whatever x needs to be to get you negative 10. Because remember, both those answers will work. 10 in here, absolute value is 10. Negative 10, absolute value is also 10. So I need to find what gives me 10 inside there. First one, take away 4, gives me x equals 6. First answer, that gives me 10. The other answer, take away 4, gives me x equals negative 14. That is the other answer. And when I do my check, I'm going to take that 6, plug it in where that x used to be, and I have plus 4 still, absolute value equal 10. That gives me 10, which the absolute value of 10, which measures the distance from 0, is 10. The other one, plug in negative 14 for x. Negative 14 plus 4 gives me negative 10, but remember, negative 10 is absolute valued and gives me 10. So both those answers work, 6 and negative 14. Absolute value equations always have two answers. Scientific notation. First step, know where you put the decimal. Decimal has to be put in a spot that gets me a number bigger than 1, less than 10. Would not want to put it in front of the 4, too small. Wouldn't want to put it between the 7 and the 8, too big. Right between that 4 and that 7 gives me 4.783. And now with my decimal there, I count how many dips it takes to get all the way to the end of that original number and count those. 1, 2, 3, 4, 5, 6, 7, 8. That is the power of 10 I'm timesing by to move that decimal 8 places to the right to give me that large number. Next one, still put the decimal so the number is bigger than 1 and less than 10. But this one I'm counting from there to the left to get to my original decimal spot. So that's going to be 8 dips to the left. Disregard the 7 right here. So 10 to the negative 7, that's incorrect. It should be 10 to the negative 8. It took me 8 dips to move to the left to this decimal spot. So 9.27 times 10 to the negative 8 describes that really small number. Alright, next page. Changing these from scientific notation to regular notation. So I take that decimal, that 10 to the 5 means I'm moving it 5 places to the right. So 1, 2, 3, 4, 5. This is the new location for my decimal. Don't leave the decimal there. Fill in zeros in the holes and then rewrite it as a large number without that decimal there. So 634, 634,000. All right, second one. Take that decimal and this time move it to the left because that is -7, moving it 7 places to the left. So 1, 2, 3, 4, 5, 6, 7. That's the new location for my decimal. Put zeros in the spot. And then I'm going to take the time to rewrite it. That answer is 0.000000432. That describes that very large number or small number. All right, second one has you multiply two decimals in scientific notation. So I'm going to multiply 6.2 and 6.2 normal. You times the numbers normal and you add the exponent. So times these two numbers, but then add the exponent number. So 6.2 times 6.2, if I do that accurately, I made a couple mistakes here. And that's still a mistake. It's okay, check my arithmetic. Gives me 14.54. I put that decimal there because I have two numbers behind the decimal here. I need to make sure I put the decimal in a spot that also has two numbers behind. So that gives me 14.54 times 10 to the 10th power. This is not in scientific notation. It's too big. I need to have that decimal right here. So the trick is, if I shift that decimal to the left one spot to make that number in truly scientific notation, that increases this number. I need to go one extra dip to the right to get that same number. So that gives me 1.454 times 10 to the 6th power. All right, Box and Whisker. The key is to find 3 separate medians. So I'm going to list it in order from smallest to great. So 2, and I have a 3, a 4, 5, 6, 7, 9, 9, and 10. It's all about medians, the middle number. Remember, average, mean, is adding these all up and dividing by how many numbers in the set. So I'd add it up, divide by 11. That will give me the mean. Mode is the number that occurs the most. This has a couple modes, 5 and 9. But for Box and Whisker, it's all about the medians. So I need to find the median of the whole set, making sure I put it in least to greatest order. And I can see that 6 is my median number. That is what we call the second quartile, the median of the whole set. This 9 is the upper quartile, the median of the top half. This 4 is the lower quartile, the median of this bottom half. So on my number line, to represent this data in a Box and Whisker plot, I put my dots on the 3 medians, 4, 6, and 9. I draw a little box through those points, connect those boxes with those lines. So middle quartile, first quartile, second quartile, and then I extend a line out with a little dot to the high and low numbers. Those are the whiskers. So the box represents the medians, the whiskers represent the high and low number in the set. All right, stem and leaf plot. So on my left, these are the stems. These are my tens digits. So 0, 10s, 20s, 30s, 40s. My leaves are the one spot. So I have 4. So 0, I put a 4 right here. That represents the number 4. For 12, 15, and 17, though, I put the 2, the 5, and the 7. That shows 12, 15, and 17. 25 and 26, in the 20 spot, I put a 5 and a 6. That represents 25 and 26. 30 for 0, I put 30. That represents 30, 32, and 33. And then for 41, 45, 49, 159 shows me 41, 45, and 49. The more you can do all these problems on all my videos, the better. The more practice, the better. Good luck.